Groceries, parcels or raw materials travel through Europe mainly on the roads. Trucks are still a cost-effective and fast way to move goods around our continent. But there is a major drawback. After cars, heavy-duty vehicles are the most polluting means of transport. Emissions are having a major impact on our climate and health, and we need to lower them as soon as possible to be a climate-neutral continent by 2050. Making the shift to sustainable mobility is urgent, and electric transport could be the solution. In electric vehicles, the energy stored in the batteries goes to the motor via a power converter, which transforms the current so that the motor can run. The amount of energy and the high voltage needed for heavy electric vehicles require power converters with advanced performance, and further research is required. To address this need, the European Commission funded a project called RHODaS.
RHODaS is a research and innovation project granted by the European Union with the main objective of developing a new generation of power converters by using the new wide bandgap devices which allow the final system to achieve the highest gravimetric and volumetric densities.
These power converters can change some characteristics of the electrical energy, such as they can hide the voltage or lower the voltage or change the frequency of the current and so on.
For the RHODaS project, we want to use both wide bandgap semiconductors that are on the market right now. This is silicon carbide and gallium nitride.
Wide bandgap semiconductors have several advantages with respect with silicon devices. They can withstand higher voltage, they can withstand higher currents, they can work at higher switching frequencies with few losses, and they are very small. So we can make power converters, a very small power conversion, and very compact power converters that can work with high powers.
And within this project, we will build a traction inverter for high powers.
By combining these new power converters with the motors, we can develop a new generation of powertrains of 150 kilowatts per axis, which means that we can achieve any kind, more or less any kind of power for the new generation of electrical trucks and buses.
RHODaS also aims at improving safety, efficiency and health of the new integrated motor drive by using predictive tools such as the digital twin and the life cycle assessment.
The integration of the power converter with the motor in a common integrated motor drive will allow us to manage a common thermal system for cooling the final prototype, which is expected to produce or to obtain a very compact thermal system, increasing by this way the final power density of the powertrain. Digital technologies will be also applied in RHODaS project. For instance, the Envision partner will develop a digital twin of the powertrain. Digital twin will allow to track the current operation of the powertrain and also to forecast the future operation. The Technical University of Vienna will develop a full life cycle analysis and life cost analysis to ensure the circularity of the new solutions.
And so it is really important to apply LCA in parallel to the product development, so that in the end you have also a solution that does not only fulfill the specifications from an electrical point of view, but you also have a product that is improved from an environmental point of view.
RHODaS is relevant for the electrical transportation because it will provide a new generation of high power, high density and high efficient power converters.
There is a challenging road ahead of us, and the RHODaS project has already started its journey. Are you hopping on?